Which of the following compounds can form a zwitterion? So first, in order to answer this question, we need to remember some things about amino acids. That amino acids are able to form zwitterions because they contain both an amino group and a carboxylic group in its zwitterion. The carboxylic group has a negative charge and amine group has a positive charge. We can simply have a following, like we can say first, when we can look at the this benzoic acid. So let's draw the structure of benzoic acid, that is COOH, alcohol, and a benzene. So this is our benzoic acid. In this we have one carboxylic group but one benzene group. The carboxylic group can lose a proton and gain a negative charge, and the amino group can gain a proton and positive charge, and it can give rise to a dipole iron. So that's why it's not possible for this. Let's now look at this aniline, that is NH2 and a benzene. So in it we can have a carboxylic group but no amino group. The carboxylic group can lose a proton and give a negative charge, but there will be no zwitterion formation, so it is not the correct answer. For aniline, it is an amino group but no carboxylic group is present in here, so a zwitterion cannot be formed. But when we look at glycine, it has structure like this. It has a amino bond and a carboxylic bond to lose, so it can form a glycine. The properties of zwitterion is it needs to be formed using a carboxylic bond and an amino bond. So glycine has both carboxylic as well as amino bond, so it is the best option for us. As far as for acetylene, we have the structure of benzene, and we have NH, sodium, and we have this CH3 double bond O. It cannot form carboxylic bonds as well as sodium as well as hydrogen bonds, so it cannot produce zwitterion. So the best option is glycine.